今天的这场专题演讲，我们会讨论在 AI 快速发展的背景之下，全球的网际网络基础设施所面临的关键挑战，以及如何去支撑未来以资料为核心的数位环境。This keynote will examine the critical challenges facing global internet infrastructure in the age of AI and how it can support a data-driven digital future. 这个场次的主持人是台网中心的丁启平副执行长。The moderator for this session is Ms. Joy Chan, Deputy CEO of TWNIC. 接下来我们就有请丁副执行长来为我们引言介绍专题演讲的讲者。And now I would like to invite Ms. Joy Chan to introduce the session as well as the keynote speaker for us. 我们掌声有请丁启平副执行长。
Good morning, ladies and gentlemen. I think that as we are going to this second day of the Internet Week, I think that we should really be proud that we had a wonderful day of discussion yesterday. We are entering the second day. I think it's very important because we are going to be dedicating today for the APNIC-TWNIC IP Open Policy meeting. As our CEO has mentioned that we do this every year and that the challenge comes every year and it's going to be more and more. And when we have looking at internet, we know that there's many different components, but the very fundamental building block is IP. One of the very building block is IP. IP plays a very important role as we see how the internet has been doing their routing and passing all the different IP packets throughout the internet. And we are very happy to have a keynote with Dr. Isaki. Dr. Isaki comes from the APNIC. He's the president of the APNIC, and he has done lots of extensive research and development in the internet world. As I'm looking at his background, that I know that he has been proposed the CSR architecture for the MPLS. For those of you who have been doing networking or routing, you know how important it is, and that's been proposed to the IETF. So without further ado, I'm going to be asking our remote keynote speaker, Dr. Isaki, to come online and share with us on his insight about what's happening in the IP world. And I also want to encourage you to ask questions because whenever that we are making all these IP policies, this is a community that we value the community opinions and comments very much. So whatever the community has, we bring to the IP open policy meetings, and then we brought up to the APNIC open policies. So that we can really conclude the comments for the different policies that's related to IP. So with that, I'm inviting Dr. Isaki that you are online, and I'm giving the floor to you, Dr. Isaki.
Then the rushing up. This is the contents I want to share with you. First one is what is AI native digital infrastructure with my understanding. The second one is IP version 6 introduction, not going to the IT, but also the OT. I deeply working with the TSMC, semiconductor giant in Taiwan, recently about the cyber security for their factory and laboratory related with IT. Cybersecurity business. That's quite important business for us. Not only the public internet, but the system connected to the internet system. Okay, the first one is my view. We human being going to the cyber complete or digital complete from the physical complete. That's a long time ago. The human being has a system run only by molecule in a very long time ago. Engines rotation power transfer with the belt and shaft at the beginning of the first industrial revolution, then going to replace the rotation hardware belt and shaft to the electricity, the copper line, then going to the physical first with bit, optimize the molecule by bits with computers or data. Then now we are going to cyber first or digital first, design molecule by bits, replacing the molecule by bits. That is nowadays human being, or we are now facing to. Then our system going to cyber complete, run by only by bits. So that is interesting, a time frame. We are now facing the legacy physical complete system going to be the cyber bits complete system. That is the underlying understanding about what the AI providing the huge impact going to the cyber first and cyber complete range, because sometimes you already know about programming replaced by computer from the human being. Already AI making this, which means the going to the human-based programming that the cyber first, changing into the cyber complete thing. Then how to making a security issue for the AI is quite important. And then the AI is for good for the attacking as well as the defensing. So that is an important, agenda we must think about. Then those three items are the AI native digital infrastructure from my point of view. First one is the going to the P2P from client server. Then we really need a distributed uncorporated trust anchor point and platform for data and functions, which is a non-human or non-computer IDs for AI native data spaces. That is the quite important next agenda we are facing too, not only IP network, but also data itself or functions. That is the chunk of the data is nowadays computer itself. So that is a non-human ID or non-computer IDs for the data or functions. For AI native data spaces is quite interesting or quite important business for us. And also, as the internet always think about the multiple anchor points for the trust is a quite interesting thing. That is same as a DNS system, right? DNS system has always have the distributed multiple anchor points in order to have the URL or FQDN resolution to the IP addresses. Same thing gonna happen in the AI native digital infrastructure with my understanding. Then the first item is about AI is the pendulum from of the P2P and client server going to the P2P system. AI has eaten only 10% of data on the existing data system, which means 90% of the data has a new market opportunity to us, or we have to accommodate 90% of data into the AI-based internet system. And also the AI system now, agentic AI, especially asking us about the new ID resources, which is a non-human, non-computer, and data. That is the overview of the internet. We have the IP network that is a common logical platform over the federated physical infrastructure. Then we have the multiple or a lot of number of community over global infrastructure. Interesting in the AI is AI going to try to communicate and integrate those virtual community over the IP infrastructure. Then how to making a trustable data transmission among those space is quite interesting, quite important thing, which means traveling among the data spaces. How to provide in the trust anchor platform to the data traveling across the data spaces that is above the IP network, though that is quite interesting and important. And also those systems, including not only IP, not only IT system, but also OT system as well. The other interesting occasion going to happen around us about the AI system is the going to from client server system to point to peer-to-peer distributed system. The autonomous edge AI system going to happen. This is the overview of the what the human being or we experience from the beginning of the Web 1.0. That's released by the Tim Berners-Lee. We have those going up, going down, distributed, centralized, distributed, centralized, distributed, centralized. LLM right now is decentralized, which going to by the AI agent, it's going to the distributed way. So that is a deja vu of the system, what we experience from the very early stage of the web services, from centralized local public cloud going to the distributed edge private cloud with physical AI, agentic AI, federated learning, transfer learning about AI edge. So that is what we are experiencing right now, especially the AI system going to the distributed edge cloud, AI system gonna running out. This is interesting. We experience the code as the content delivery networks. Used to be the web system was point-to-point at the very beginning, then the centralized client server system, which went to the hierarchical client server system with P2P. That's the history, right? The same thing is happening in the AI and data business as well. So regarding the computing and data center business, computing as a service across the data spaces, that is happening right now in the AI native infrastructure. So we have to come up with such a situation, not a simple IP system, but also more complicated data transmission system we have to think about. Then experience we had in the DNS system, in the data system for the AI, we have the good experience and knowledge how to making this infrastructure, I believe. Right? And then the other one for the AI native data infrastructure is toward IOF from IoT, not the Internet of Things going to the Internet of Functions. That is kind of virtual machine. Any virtualized the technology going to the Internet of Functions. When we carefully look at the history, the past was physical first, as I mentioned at the very beginning, which went to the now digital copy in cyberspace called as the cyber physical system that has been discussed 10 years ago, I think. Then it is the, before the cyber first, the physical first. Physical domain is a God. Then we got a digital copy in the cyberspace, then has a simulation analysis, the data analysis, then control by the printout by the computer or put the devices into the physical systems, which is a copy first, code second, right? Then in the code second, we now introducing AI, changing from the human being programming to the computer programming thing going to happen, which is the cyber physical system that is the Internet of Things changing into the Internet of Functions. That is the AI system has been accelerated to this. Then the whole of the system design, system structure going to be changed from legacy computer hardware-based network going to the functional-based Internet. This is the actual auto navigation of the vehicle system. That is the same bitmap system was the legacy system. So in order to have the clever, smart auto navigation for the EV, that is going to the digital world, which means the bitmap system was kind of the bogus digital system, but we are going to those kind of AI native or semantic data, space management and space business that's happening right now. So that is the changing from digital copy in cyber, going to cyber first. Programming or design is going to be complete in the cyberspace. Then some of the data, some of the object going to print out in the physical space. That is nowadays we have. That is kind of software-defined infrastructure. Then the digital space management is quite important and very critical. So that is the view of the simulator and real world about the vehicle system in about 3 or 4 years ago. As you can see, simulator world almost same as real world. Real world cannot have snow, especially in Taiwan, right? Or heavy wind, strong wind, or heavy rain. That is quite hard to have in real world. Though in the simulator world, any type of the condition computer can make and evaluate the performance of the system quite easily. That is now. I mean, real world and copy first is going to change to the cyber first. That is now the AI is going to accelerate it. Okay, then that is the think about what the system design should be changed. Before you, especially when I talk with the TSMC, for example, they're always having the digital twin in the computers. Then they have the changing the system in the computer first, then simulate and evaluate the system. Then best one is going to implement it in hardware and software, actual software, right? The third one for the AI native digital infrastructure for me is a cyber first with digital native data. That's the kind of semantic data from bitmap data thing. Then the native digital data going to go from the bogus digital data. That is again, what the AI is going to do. Say the very first AI was taking care of the bitmap data. That's the recognition of object from the bitmap. Though recent AI, starting from the digital native data, then print out the bitmap for the human being. So the digital native data among the computers, they never output to the bitmap, right? So that is the fatal changing the system from the bogus digital system to the native digital system, which means the value or the data itself is quite important for the future networks. So that is a code first with the semantic data, AI native digital data. Then you can print out wherever you want, whatever you want. That is going to change the hardware infrastructure quite easily based on the cyberspace calculation. That's the reason why human beings need huge computational infrastructure and resources for human beings. And also, those computational objects must have the data transmission among them in order to work well in the cyber domain. That is, say, internet in the cyber domain among the AI object. Right? In order to have those AI native infrastructure, again, trustable anchor points for the data or function. Function means the kind of, the processes or virtual computers and the semantic data among the data spaces. So that is, again, the same business we have to do in the data spaces as the DNS system we have, I think. They're quite similar business we have to have. The second topic I want to touch on today is the introduction of the IP version 6 into the OT system. This is the IP version 6 single stack for the by the Apple, Google, Amazon, initially for the smart home, as called as a Matter run by CSA. That is now going to the building system and data center for AI. As you know, all of the big tech players in data center having an IP version 6 based server system that going to not only servers but also the facilities. Most of you guys know the IP version is mostly network gonna
Dr. Isaki?
Microsoft Windows 11. Okay. That's going to be, real business operation, which means version 6 single stack operating system is now available in front of you. That can be used for the IT system, conventional IT system, but also OT system. That is the member of the CSA for the matters thing. As you can see, Amazon, Apple, Google, those are the main player for the CSA initially, as I mentioned. That's for, say, smart home. Though, when we look at the recently, Siemens, Schneider, Infineon, Legrand, those are the player of data centers, which means, I think, apparently, the major data center with the AI going to introduce TCP/IP based, facility control or power control that is every single critical infrastructure design. That is not only the IT system, but also OT system. That's the reason why TSMC is now quite interesting about TCP/IP based factory and the laboratory facility management and control that was not connected to the internet. So now every single device is in the semiconductor factory connecting to the internet. And also that data is going to be collected in the factory, then analyzed by AI and controlled by the AI. That's recently that they are now going to do. So that is the two major topic about AI. AI is not only IT, but also the OT. And version 6 is going to introduce into the OT system. That's a huge business expansion, and also the new business players who do not have any experience and knowledge about TCP/IP. That's a huge business we have to have. The last one is the NTN, non-terrestrial network, and the subsea cable system. Used to be basically internet was implemented as a surface on the globe, on the earth, that the terrestrial, including undersea cables. Now we have a non-terrestrial network that is independent of the national boundary in the physical way, which means now we have real, non-governmental network which covering the global earth. So that is the quite critical, management and governance of the internet system that is completely different infrastructure we are going to integrate into the existing international based, internet. The other one we have to think about is the cooperation with energy system. That is again the AI system going to, providing in front of us because of the huge energy consumption by the AI system. That's not only the data center, but also in your every single devices. The energy issue is another critical business about the IT system digital infrastructure. So that is the reason why Japanese government is going to having a kind of energy and the telecommunication, a collaboration called as a Watt-Bit Corporation. Energy business and the a digital system has to be married into the single system. Otherwise, the system cannot run. So this is another quite critical issues we have to solve. We have to think about. That is the infrastructure. Think about the latency issue. That is another challenge because of the other huge latency is coming from the moon. You have to think about. So this is the last slide today. The future issues or challenges is the government involvement by stakeholder. That though the NTN is quite new area on the moon. On the physical infrastructure point of view, energy consumption issue by the AI and the non-terrestrial area. The last one is the how making a data trust or function trust in the cyber domain. That is the across the AI native data spaces. That's all. Thank you.
Dr. Isaki, I'm going to ask you to say just a little bit more, just to see that if there's any questions that coming from the floor. But in the interest of time, we're going to be very, very agile and maybe a little bit clumsy, but we're going to move the chairs up for the next session, please. And also, we're going to be, I know the time has been shifted a little bit, but I'm going to be welcoming you for the next 3 panelists to talk about in the real world, because Dr. Isaki, you really mentioned a lot of things earlier when I took a peek on your slide. I know it's wonderful, but there's just much, much more when I'm listening to you. I hope this is also worth the wait for all the technical difficulty. But we're gonna run this very well, just like the network has to run, right? So please, my panelists, if you are ready, when the chairs are ready, please come up as accordingly. If there's any questions from the floor for Dr. Isaki, I'm sure that there's a lot after this very inspired keynote, but if not, I'm just going to move on because I hate to take away your time from the break that we're going to have after this.
All right. Thank you very much to Ms. Joy Chang for moderating the session, and thank you to Dr. Isaki for your informative sharing. 那接下来呢，我们就会进入下一个场次。